Hello, welcome back, everyone. Let's start with the new people that I see on the call. This is very exciting to see new people. So I will name some names, and if you will, please do a quick intro of yourself and why you're interested in the stuff that we have here. So M Gilda.
Yeah. Hi, I'm Michael Gilda. I'm co-founder of Antmicro, and we've been kind of brought in here by Drew, with whose team and a bunch of other people at OCP were talking about PCIe fault injection using an FPGA framework we're proposing. So that's the reason for being here. I mean, the topic area here is interesting in general. But specifically, we didn't know about this meeting until, of course, Drew invited us here. So nice to meet you. We're actually planning to get more involved in OCP going forward, but so far we haven't been very active.
Very nice. Thanks for that. Welcome. Drew, I'll keep you for the last because I know you have a presentation from Dan, so you can also start with that. So next up would be Peter K.
Hi guys, my name is Peter. I'm an hardware engineering manager for Antmicro, and yeah, I'm here for the reasons that were mentioned previously by Michael.
I see. Thank you. Welcome. Carol?
Hello. I'm also from Antmicro, but I'm leading like software RTO team. The same reason as Michael and Peter, because of what we do with Drew and PCI testing and fault injection stuff and all that stuff.
I see. Thank you. And yeah, the last person in Lira, Citygate 35. You are not muted, but I don't know if you're saying anything.
I can introduce Peter just to save time. He's our CEO and obviously joining for the same reason.
Okay, thank you. So everyone has come as a group. Welcome. Go ahead, Drew, and you can also continue with the presentation that we have for today.
Okay, sounds great. Well, thank you for inviting me. I'm really excited to be here. I'm Drew Walton. I lead fault management work at Google and also across OCP. And with fault management, what I thought I would do is have a few slides to share, and then I just have the presentation from the Antmicro folks. So if it's okay with you, I will share those things and talk a little bit about the fault management efforts. So overall, in OCP, we have fault management efforts that are trying to gather rich error logs. And so the notion is that we want to drive as rich data as possible to analyze failures and to do the best we can to mitigate them or to get the system repaired. And so we're working with vendors across the industry to develop a RAS API that allows us to log anything. We're driving things like the OpenBMC hardware fault monitor, where we can aggregate error logs and try to correlate things that are happening with power and the chipset. We also are working with folks like NVIDIA and AMD on GPU fault management. And then we have an effort with the memory vendors to analyze memory errors. All of these things, though, are about error handling. And as we dug into kind of our pain points, we realized that PCIe was significant. And here you can kind of see our value. We collect data, we decode it, we analyze it, we can query large-scale data, and the end result is better TCO, MTBF, reduced business risk, and minimizing human toil. And so it all sounds good, but how do you do it? And we want to talk a little bit about PCIe today. One of the problems with PCIe is that the spec has a lot of flexibility. It works on everything from a Raspberry Pi to, the DOE supercomputers. And that flexibility sometimes creates ambiguity. And just as an example, I was working with Intel on this a little bit, and we found a device that reported a malformed TLP when it could have just reported an unexpected response. Either response was appropriate within the PCIe spec, but one of them means you have to reset the machine. The other means that the driver just handles the error and the machine stays up. But because we haven't defined what we want the errors to be used for and how we want them to be signaled and how we want the system to react to them, we have this ambiguity, and it doesn't play out well. We also don't know how to configure PCIe error handling. We had a problem where we were getting UR storms, and the vendor we were working with, the silicon vendor, said, well, what do you want to do for URs? And we had to have a debate in Google on how we wanted to handle them. And URs are kind of an extreme case because sometimes, they mean you're probing the system for a device. Sometimes, though, it means that, like a DMA failed and you need to stop the operation. So we need to sort that out. We also want to figure out what should happen for each error. Do we want to reset the machine? Do we want to pull the link down? Do we want to replace the device? And today what we have is a bunch of special cases. So we get a BIOS from someone, and we bring that up. We work out a few problems in our new product introduction. And then as new cards come in, all of a sudden things start breaking on us. So we end up with unpredictable deployments and reliability problems. And we've had a few cases where we've had emergencies, where we've had to stop and work with urgent customer problems. And all of this is because of this ambiguity. So what we want to do is we want to define settings for PCIe errors. And Erwin Saar at Intel made a proposal to the Hardware Fault Management Group in OCP last week that was favorably received. So we're going to try to define how we handle errors at the device, at the switch ports, and at the root port. We're also, on a team I'm leading at Google, working to propose an AER driver improvement. And we're going to bring that back to OCP. Our intent is to make it so that we can expose error logs in a structured way rather than just writing dmessage, and so that we can change things at runtime with runtime kernel patches if we find that PCIe is misbehaving. And of course, it will implement whatever the defined settings we want in the row above. But then, as we do that, we realized we needed to create standards for when PCIe devices should use particular errors. Also, DPC, downstream port containment, which is a feature that allows you to take a fatal PCIe error and make it a corrected error by bringing the port down. It isn't implemented correctly across the industry, or maybe I should say what correctly means isn't consistently understood. The spec left a few things open, and that means that DPC is not a universally usable feature at this point. We need to fix that, because it's going to be extremely valuable to hyperscaler fleets. And then we're also proposing improvements to the PCIe spec, things like error logging queues that will allow us to get the transaction headers for every error, where today some errors don't get transaction headers. They're followed by an error that does, that's related, but because we've logged the first error that doesn't have the header, we don't get the header at all. And now we're wondering what caused the problem. So all of this sounds great, but then what are we going to do to test it all? And that's where we're coming to you today. I just want to give a little bit of context on why do we care and why are we doing this stuff. And so the folks at Ant Micro have been working with me on tools like Rowhammer, where they wrote in Python a DDR5 memory controller, synthesized it to run on an FPGA, and built a piece of open source software and hardware that allowed us to explore Rowhammer patterns on DRAMs. It was a really great tool, and it's on GitHub, and we've had people build this tool independently of us. And so we were talking, and I was sharing some things I was working on, and they said, oh, would you be interested in doing PCIe error injection? And my answer was, absolutely. And so what the folks at Ant Micro proposed was taking an FPGA-based board and using its DDR5 PHYs and having an open source auxiliary board we plug into it that plugs into the host, plugs into the card under test, it can intercept packets and manipulate them. So if I want to do things like flip some bits to trigger CRC errors in a PCIe transaction, I can trigger PCIe link level retries, or I can insert a poison TLP, or I can even just turn the next MMIO access into a poison TLP. And so it's extremely flexible. Our goal is to build an open source tool with the industry that will allow us as a group to come up with a tool that we can share amongst each other, where we drive the silicon vendors for devices and for things like root ports to behave in the way that we expect, so that we can write software that works more universally across data center PCIe devices. So that at 10,000 feet is the proposal. The folks at Antmicro have an excellent track record with us on several projects, and they're actually working with several other companies within OCP. And what I'm really excited about is that this is an open source thing. So if I find a problem with a PCIe device, I can tell them, get this, or download this, build this board, or maybe because it's going to be inexpensive, we just send them one and say, here's our test. Here's how it's failing. Go reproduce it. Here's a script. This you just execute this command, you'll reproduce the problem we're seeing, and here's how it doesn't meet our standards. And so by doing that, I can drop this into any system. I can run a suite of tests and ensure that I get the behavior I expect. And the end result will be fewer late-breaking surprises, fewer emergencies with customers, and more predictability in getting PCIe devices working correctly. So that's the really rapid view. I want to pause now because I've just been talking rapidly to see if you all have any questions or feedback for where I'm headed.
I can start with a quick question. So this is pretty cool work. I'm very interested in how this intersection card is working, and possible debugging and manipulation of the data as it's going through. And clearly what you're saying aligns with what we're trying to do in this group as well. So like reproducibility of the test and being able to have identical environments, so that you eliminate external factors in when we're trying to debug something. My question is, I guess we need to get into a bit more details about the interaction here. Like I understand there's like a software piece to this, there's a hardware piece to this. We're kind of more aligned with the software things in this group. So I will ask whether you are considering using the test and validation spec to facilitate the data collection out of these diagnostics, or do you have something else in mind?
So this card has a RISC-V processor on it running Linux, and we can run whatever tools we want. So I'm not trying to define the test framework or how it interacts. I'm trying to focus on injecting a flipped bit in a packet. So I work with Dan. I work for Dan. So we will, I think, want to plug this card into whatever framework is being developed for testing across the industry. So I have no opinion there. I'm pretty flexible. I don't have an answer for you because I'm not working in that area. What I want to do is flip bits and make errors happen.
Okay, I got it. So question is more towards you, Dan, in this context. Maybe you can act as the liaison here.
Dan, you're
muted again.
Yeah, sorry, I was typing earlier, so I didn't want to bother everybody. Yeah, I think what Drew presented here kind of breaks down into two parts, right? There's the work that he's doing on sort of fault management in general and all the RAS functionality and the CPR logging. That work is already integrated into, well, what was the OCP Diag V1 format. Like we're bringing that in now. Like we do it through both measurements through this decoder and then also through the artifact extension. So we bring over the raw CPR log as well. But for this particular card, I don't look at it as necessarily integrating to the Diag framework per Drew's point. I look at this as like a validation vehicle for the Diags that we have developed, where we can verify that they're working the way we expect. So the reason I'd asked Drew to present is all the work that we were doing on the LMT, for instance, right, and those particular Diags could definitely benefit from having a card like this where we can go in and we can validate that, you know, they're doing exactly what we expect and different architectures, different CPU types, all those things, right? We have a card similar to this now called the Williamson card that we developed internally, but it's all proprietary firmware and, you know, everything else, right? This here, and particularly bringing in Ant Micro, would give us the ability to have open firmware on the card where really in the future, you know, it's an FPGA, we could have it do anything we need it to do, right? And then I think the piece that would touch on Arun's world is, you know, having this card installed in sort of your CI/CD gives us the ability to do a lot of things that we just can't do right now through software injection. We just don't have those tools yet, right? So I think that's kind of how it comes back and, you know, integrates in with really not just one thing, but multiple things going on in this group right now. I don't know if that helps.
And the thing I'm really excited about, just to add to it, like we had an internal card that could inject packets, but this doesn't just inject packets. This can alter packets on the fly, and that's a whole nother level of power. And my experience with this kind of project is that if I find that I want a new feature, I've done pull requests to Ant Micro. Ant Micro took them in and they showed up on GitHub, and there was a new feature in the tool that I wanted that was added for me and kind of by me. So by having it be completely open, we want to make it something that you all can take and add to. And so with that, I'll shut up. And I think there are a few raised hands. I guess Francisco, if I'm saying your name right.
Yeah, thanks. So, I mean, this is very interesting, and I think that it allows for all the types of errors to be injected. In terms of the signal integrity related ones, I actually took down a lot of servers by mistake using LMT wherever it's not supporting the independent sampler. It's actually introducing real noise. And that one I see as a very much compatible tool when comparing to this to create many of the errors. That means a bunch of correctable, and then when the signal integrity becomes bad enough, they become uncorrectable. The device falls off the bus. So it creates a fairly real life experiment, as opposed to this one that seems to be mostly digital. So I'm a big proponent of actually making standard, and LMT was one of those things that it's one of these hidden gems that the industry created, and I think we have not made use enough yet of that feature. And in general, as a standardization process, I would like to see that the injection capability is also becoming part of the PCIe spec, wherever it isn't already. So I think that it's great to see this. It's great to have a tool like this, but in the future, it would be great to see that this capability becomes part of the PCIe stack.
I'm fully aligned with that, and we're constantly requesting better error injection. In fact, one of the key things I've requested is the ability to pattern match an address and poison a TLP without having to inject an uncorrected memory error and then convincing the driver to read that. So I've tried to say, here are the really hard errors to inject. Can you help us start there? But ultimately, I would love to get whatever I can in the spec and make it mandatory. Or maybe what we do is we have a data center spec where we have a higher expectation for what's injectable so that we don't, because I think if we say, well, every link has to have this, the Raspberry Pi folks might push back. But I think in terms of data center, I'm fully aligned and I'm eager to drive it as far as I can. However, having said that, the notion of having an independent tool where I can trust but verify is still handy. So even if I could inject an error using a tool, having an independent tool that allows me to inject it and see it and manipulate packets it still has its place.
So I find that having this available right now is pretty nice, both the hardware and the software. Question for you, Dan, since I'm trying to figure out a collaboration model based on what we've discussed so far. What would be the first thing that we can do at this point? Like, do we want to incorporate a new diag that leverages this FPGA cards, or do we want to, I don't know, maybe explore more on the fault injection part? What do you think?
Sorry, I was going to say, I think the first thing we would do is one, we actually need to materialize the card, right? We've got, a budget set aside for doing that. And then once we have it, start with something that we've already got, like the AER diag and PCIe crawler. We can use that to kind of go and inject various errors, make sure that we're catching them, that the AER functionality is working the way we expect and things like that. And then I think the next logical step would be to drop it onto the work that Arun is doing. Because so many of our problems with RAS and sort of PCIe functionality and whatnot, they originate from BIOS and BMC and all the areas that, Arun is focused on right now, right? So that seems like the logical first step for me. And then we would bring it into LMT and other things. But what I really wanted to get out of having Drew come in and present today is, the big gain for me here is that we'd have the open source software running on the card, right? I mean, that's the new novel thing that we're bringing in. Is there interest amongst HP and Meta and people that would be interested in collaborating on this, right? Like, we want the card. I think to Francisco's point, we can get a lot of cards that do things like this to our vendors, but they typically come from, Agilent and Keysight and folks like that, and they're very expensive, right? We're not going to drop them in every single slot. They can do a lot of the things we need. They can introduce a lot of errors. They can introduce, analog noise and things like that this card won't be able to do. But they're high dollar test equipment. This is something that would be like very, very fungible, right? Is it something that you guys are interested in and would want to participate on, I think is the question.
Go ahead, Vincent.
Hey, I'm sorry, I'm on the move, so I'm not on video. I was going to ask something else, but then just to tackle that question, not to leave it hanging, I can't represent all the groups within Meta on this, but I know we've had prior very similar interests. So I would definitely say for the lab validation work that goes on, this is a very, very high interest. One thing that we will do and working with others is to see on the ODM side, right, on the manufacturing side, whether this is something that would make a lot of sense to equip those environments in the R&D labs at least. So that's something I can definitely pick up and inquire. I'll let others jump in on this specific point. The question I was going to ask is, as part of this work, is there some clarity around what's missing in the diag V2 structure that has emerged that could become sort of a pathway for enhancements to the diag, or do we have evidence that V1 or even V2 is actually sufficient to support the use cases you've implemented with the diagnostic card?
Yeah, we're doing V1 now. So, I mean, that works, which if V1 works, V2 should work as well. I think the question is what is the right amount of decoding of the data we pull back right now? Like, we're decoding quite a bit of it and putting into structured measurements. Is that the right approach? Like, it's good for us. It makes analysis easy. But if there's something else in that CPR log that you want that you didn't pull at the time of extraction, it becomes a headache. So I think that's the answer to this. But Vincent, I want to highlight another use case for you in particular. Not just for like the validation lab, but I think in L6 manufacturing, cards like this, have a lot of application as well. We typically take, a card similar to this and we'll drop it down into every slot at L6 to basically do all of that. In which case that would come back and factoring in, like, if you're interested in that application as well, how many of these are we going to spin up? What is the cost of each board? Like, all that will matter, if we build, 10,000 of them or 50 of them, right?
Yeah. No, absolutely. That's a very valid use case, and one that I've been in conversations where this has come up, and it's been an animated discussion to say the least. So the point is not lost. Okay, cool. Thanks.
Yeah, honestly, like, maybe one more point. I apologize for jumping in front of other people. Like, when we use golden cards for this, like, we put in, typically the cheapest card we can find, which is some type of nick or something for validation that we can generate traffic with. Like, it really leaves like a gap in not only test efficiency, like there's faster ways we could do this, but also just capability. If we want to go and validate the software, validate the fixtures, do sort of like CI/CD on the test bed itself. Like, error injection helps, and it's hard to do that with the NIC cards, right? We end up doing a lot of like, just banging the register space and stuff like that. It leaves gaps.
So I see you, Francesco. I have a quick question. I may have misunderstood earlier. So this card with the FPGA on it, this isn't being produced right now. Like, is it available?
No, this is a proposal, and so we're asking people to join us in the proposal. If it was available, I would give you a Get link and just tell you to go there, and you could download everything and build your own.
Okay, that was exactly my question, right? Because if we want to drive adoption, it would be nice to have something to do a demo or a hands-on experience with.
Agreed. I think the key is right now we have a proposal, and what we want to do is get feedback from you all and find out who's interested in collaborating with us to make this happen, because it may be that you have some requirements that we're not aware of, and that if we just hear you out, we could make this more interesting to you. It may be that someone has a strong opinion about features they want that maybe I don't care about. But if you want to get involved and drive those features and help us get this card done, then you're welcome to do that, and you're welcome to add things. So it's really, we're coming to you early with a proposal and want to see if you're interested in working with us to make the proposal happen.
Yeah, that makes sense. So Francesco, I think your opinion is very relevant here. So go ahead.
So in terms of requirements, when we say a card, that's where I don't know exactly what we mean. I think in our systems we have NIC cards with OCP connectors. We have M2 connectors for SSDs. We have pods defined in OCP for GPUs. So a card in the sense of plugging my GPU into a Razer card as if this was a desktop at my home, it's probably not a viable thing. And in terms of fitting in some of these systems, if I think of a pod, the pod attaches to the board. If you actually spliced something in between, I would no longer be able to fit my shelf in the chassis. So in terms of mechanical, it's probably extremely difficult to make something that fits a lot of needs at the same time. So I was wondering if you thought about that. What was your proposal there? It's usually easier to fit it in PowerPoint than it is in real life.
And what we do, we do a lot of PCIe accelerator development, and we tend to have cards like this, and we have a flex cable or something then we lay it's for lab debug, so it doesn't necessarily need to fit into the machine. Or like in our factory testing, when we have these interposer cards, we build a fixture that allows us to put the actual card, like if we're doing a PCI accelerator, we'd have a fixture that guided the accelerator into the interposer card. But you can see that we have an FPGA board on the left and then a mechanical solution on the right. But the mechanical solution, I think, could vary. If someone wanted to fund a different form factor board that worked better for your system, I don't want to speak for Antmicro, but Antmicro folks, I think you'd be open to that, right?
So
Michael?
here, what you're saying is that mechanically, this is a card, and the FPGA unit actually is plugged into this through cables that can sit anywhere.
Well, it's an off-the-shelf FPGA module.
Yeah, so basically,
essentially, the mechanics of it are, completely up to us, right? Like this is a proposal where, we just kind of looked at it and thought that makes sense. But of course, we definitely don't have everyone's mechanical considerations in front of us to say what's going to be the best solution. But as Drew said, like there could be multiple cards. Ultimately, much of the work, of course, lies in the infrastructure, the FPGA code, etc. Right? And the cards are, of course, a necessary and important element. But they're not like, they're a little bit disposable. Like you could build different ones. Those interposers are going to be cheap, and everyone could have their own if they needed to.
The one shown on the document, I personally, I don't even know if we have a single server that has the regular PCIe connector. And so.
Yeah, and I think we just that's where you might want to jump in and add some requirements and fund development of a board that meets your needs. And if you look, this is currently an off-the-shelf FPGA board on the left. It connects through this FMC connector to a card that does the interposing. And so that's what you see below here. And, but I could see us if it was convenient, I think it's conceivable that we could even build the full card, not have a separate board. But it's kind of nice to have the separate board, because if you wear it out, you just replace the board, and your FPGA, which is the expensive part, is still good. And if you have an M2 connector, you want an M2 interposer as opposed to a Chem card edge connector. It's just a different board you plug in, and you can use the same FPGA. But I think I'm personally very open. It sounds like Michael's open. So, if you have opinions and want to work with us on the form factors, jump in. I think if you have a unique form factor, we'd want you to help fund it, though.
Yeah, I think that's really what it comes down to. Like, we would pay for the development of the card and, fund the initial software. But for different connection types and things like that, that's where we're really looking for, the wisdom of the crowd here. Like, what would we need to bring in? What cable links would we have? What physical constraints? I mean, you guys are just like us. We'll run PCIe over a wet piece of string, right? We have all kinds of interesting connections for it. Right? So, like, we're never going to know all your weird connectors from all and everyone else, right?
So I think a bit of clarification here would be to declare the environments where this is used, right? Because if it's a lab environment, then I don't know, just put something in and keep it open on the desk or something, right? But if we're talking mass production or inside the DC, then we have like different requirements, including this mechanical discussion, but also like usage patterns. Like, is it expected to debug such things on a random server in the DC and then go to manufacturing with it, or to the ODM and say, okay, reproduce this failure that we randomly found in production or something like that. So this is a large topic, right? I'm only mentioning it.
We need your help, because we don't know the answer. So that would be great if you could help us figure that out.
Yeah, so my take after this conversation with the FPGA board being a separate board, and in general, this being a fairly difficult thing to fit into a system, unless you design the system around this thing. I would say that this is a benchtop experimentation thing for error injection, and a very useful thing at that. So I think that validation of an ASIC functionality, validation of an FPGA design functionality, validation of a new CPU architecture, all that stuff, I think that this would be useful. And I think that if we keep it at the benchtop level, while the volume is lower, the problems of the mechanical constraints are probably much less important. And in terms of using it everywhere else, I really can see that we would want to inject an error in a production system on any one of the production systems. So I don't think this is going to end up in every server on every slot by any means.
That's right, and I think we have some form factors where we might be able to slip this into a data center build if we built a custom. If we took the FPGA and built a custom device, and maybe we would put it in a case where we had an emergency and we're trying to debug something critical. But I think that we'll have this in pseudo production environments where we're doing testing and the mechanical constraints aren't it's not quite benchtop, but it's like a lab that's in our production environment where we don't have to follow all the mechanical rules, because obviously we're probing the system and opening things up to look at. But I don't know, that was kind of my bent as well. But like I said, if someone else has another idea, I think the key is to give us the requirements. We'll work with you and see what we can figure out.
I have a question to throw your way, Vincent. From a manufacturing standpoint, do you think we have the right people on the call right now to be interested in this, or can we share this document internally and get more eyes on it?
Yeah, there's I think definitely need to spread that one a little further, and I can certainly do that. I don't think we have the right people to comment on that one.
Hey, and by the way, I work a bit with Anil Agrawal. If you're, I don't know you, the person on the phone. But if you know Anil, if you loop him in, that might also be helpful for context.
Yeah, absolutely. Anil and Francesco work closely together as well. But absolutely, Drew, appreciate the ping on that. But there are other folks on the manufacturing side who can help us with design manufacturers who would probably have interesting things to say. So I'd like to put that in front of them.
Sounds good.
So before you go, Dan, can we share this link that we have right now? I know it's gated for sharing. So sharing.
Well, this is Ant Micro's. So this is a proposal that Ant Micro wrote at my request. So I think I defer to Ant Micro, and I think if Michael, if you need to give us parameters for sharing this, or should people just send you requests and you'll approve them, or how?
I keep approving them, yeah. So I'm fine with just keeping approving them, if that's okay. I mean, it's kind of also gives us an idea of who's actually reading it. It is a nice kind of piece of knowledge to have, but otherwise, of course, it's not meant to be secret in any way. Ultimately, the framework is planned to be open source, of course. So it's not nothing in there, no technical knowledge in there is secret. So yeah, go ahead and share it as needed. I'll keep approving those share requests. There might be, of course, a delta T if I'm asleep or something. But otherwise, if I see like a Meta or Microsoft or Google or whoever else at OCP requesting access, I'll just automatically accept that.
Okay, thanks for that, Michael.
Just so you all know, they're in Europe, so that's why there may be a delta T. Is Antmicro's in Europe?
Go ahead, Dan.
Yeah, just 2 proposals and a question. For the proposal next steps forward, it seems like maybe what we should do is get a little doc together with open questions, any concerns that anyone has, and then anticipated use cases as well, and then we could kind of see what we have in common. So I can take an action item to get that together for Drew, and then if we can get kind of fill out from all the participants for the folks that are interested. And then a question I had for maybe Drew and our friends from Antmicro. It would be good, like we've done a lot of work in this group in open sourcing code. We haven't open sourced any hardware yet, but I went through that process on a few other OCP projects. I know a lot of times the FPGA vendors will provide like a reference design for the PCIe card and things like that. But if we wanted to open source the hardware as well under OCP so people could go and order up some of these cards, particularly if we have some type of like mezzanine sacrifice connector on it, right? Is this something that we'd be able to do as well, or is the design shareable?
Absolutely. That is actually foundational to this proposal. And so, in fact, Antmicro uses open source tools for developing things whenever possible. So if you go to this link that I proposed, this is our Rowhammer board on GitHub, and it has instructions for downloading all the tools, for the board, the files, and everything. So you could build the hardware from scratch with everything on this GitHub.
Okay, that's fantastic. Thank you.
And I'm sorry, Michael, I don't mean to speak for you, but that's foundational for me. That is what sets this apart from everything else. And I know that's Antmicro's bent. So, Michael, tell me if I'm not speaking for you well, but I think that's pretty foundational to all of this.
No, I think like I'm so happy I don't have to, kind of speak so much myself. I usually do the talking for these kind of things because I guess that's what sets us apart from many other people. Like we work with hardware quite a lot, but we're very open, and that's perhaps not very common in the hardware space. So whatever we were developing in FPGA and software and hardware too, we open source when we can. Of course, like there's sometimes limitations with what you can do based on like existing licenses and deals and needs of specific clients, right? But whenever it makes sense, we definitely recommend things to go open source, especially in groups like OCP. And here, of course, like there's in the document, there's a explanation of how it's going to go step by step, right? So I think it starts with like leaning on some proprietary components initially, and then goes on to like open source more and more of this. But that's kind of something we've done many times. And as Drew said, he's referring to this Rowhammer tester project. It's completely open source, and that's the goal here as well. Completely shareable. We have, I think, probably like I wouldn't say most, I do believe we have unique experience in enabling open sharing of hardware. We're also working in Chips Alliance and other groups in RISC-V, specifically with hardware open source, which is sometimes, of course, a bit more difficult to handle than software. But we know how to deal with this, and of course, we are a partner of Xilinx's and et cetera, So we can make it happen so that we don't step on anyone's toes or do something that someone wouldn't like. We'll just share everything that's possible to reproduce the entire thing from the boards through the FPGA firmware to the software framework. Ultimately, of course, reproducing it takes some skill and money, right? It's not that every person on the street will be able to build this, but definitely this will be will decrease the barrier of entry like as much as we can. And I think that's going to be radically different than any other solution you can do here, because most of the time, if you want to buy like specialized PCIe equipment, you immediately go to the category of very expensive and very proprietary equipment, which is not this. This is going to be quite a bit different, both in terms of cost probably, but also in terms of just your ability to customize it however you want.
Thanks, Michael, and thanks, Drew. This discussion has been very interesting, and it is certainly exciting to have both software and OS hardware to go with it. I think at this point we're gonna go and share this document with various people and get some more opinions, and we will get back with whatever interaction we find. So that being said, I'm gonna change the topic a bit if there's nothing else to add here. Then you have another item on the agenda. I see Young is on the call, so.
Yeah, I did. We'll get back to our regularly scheduled agenda. If you guys want to drop off, I know you're in Europe, so definitely. Thank you so much for attending today. We really appreciate all your time. Drew, thank you for helping to pull everything all together for everyone.
Well, thank you. I'm just glad to work with other people that care about this stuff. So I'm very excited to work with you all.
You got the right group here. The question I wanted to do was I wanted to pivot things back to our work with Microsoft and on virtual client to see what progress we're making there. We're using the virtual client stuff. We're planning to use the virtual client stuff for one of our next phases of server validation to add some what we're calling optionality into our workloads. And I was just kind of curious if there were any updates on your side, Young.
Hi, Jeff. Unfortunately, I have not got any feedback from Sergey after maybe 2 weeks ago. I checked with him, I think last week. I haven't got any response. But meanwhile, there's a couple updates on virtual client side. So first, we moved to .NET 8, which will reduce the footprint on the underlying hardware, especially on ARM. Then I don't know what's the next hardware project on your side, but .NET 8 has lots of performance improvements, especially on ARM. And we also made a couple changes to MLPerf workload. So we previously only had MLPerf inference automated because for training, you will need to download a lot of data, and the processing of that data takes days. And we just onboarded MLPerf training, and the strategy we take is we will pre-process the data, and the pre-processing will not be benchmark basically, because that part is the processing is a one-time change, and it's not a critical step in any like LLM modeling training steps. So we pre-process the data and then put that into storage. So the training step could be finished by like one or a couple GPU machines in a couple hours. So.
Is your plan to bring in the sort of pre-processed data into the Git repo so it gets downloaded along with the what I'll call the workload?
So we maintain a storage account. Like the data is way too big for GitHub. I think up to terabytes of data. So yeah, we put that into like an Azure storage account, but you can download it.
Okay, so then I suppose then the thing is you download your terabyte of training data, put it somewhere safe, and then somewhere in the workload you can figure on where it picks that up. Is that correct?
Yes, and it's all by default configured, so you don't need to know about these.
Okay, sounds good.
Yeah, let me know if one second is back.
Yeah, and then I didn't know you were waiting on us, so I apologize for that. Let me get with Sergey and see where he's at.
Okay, yes. Let me know if you need anything. Yes.
Okay. So since we're on the status side of things, I'll do a quick status on how things are right now. I know you're interested in this, Dan. So out of the diags that we had for this year, or for the summit rather, so we had SAT, we had memtester, PCI crawler, and I think the SSD ones, but I'm not sure those were actually committed. So
they weren't on our plan for the summit, but we did say we were going to try to get them done this year, which I know they are in flight right now. I've seen them.
yeah, I just wanted to get like we're in December, so like it's like the end of the year, so I'm trying to get like a status of everything. So mem tester should be working right now. Igor already merged the PR. It produces the output. Everything works. Set is already working. I've actually tested that a while ago when Dylan was still here. We haven't yet gotten to the OSFCI part with the HP, but it should be working. Like I don't expect any problems. PCI crawler, I was finishing up the last iteration of the PR review today. So I am expecting this to be merged by next week. Also, I think we can officially say that the status of Paul being back. And on the SSD, am I missing something, or was this all of them, like the 4 ones?
Those were the 4 that we had, and then anyway, finish up your thought, and I'll add something.
Yeah, on the SSD ones, I would ask Venkat for an update there.
The SSD test cases, I think the open sourcing part itself is, I think, mid-January is what it's trending towards, but the OCP diag part of it will follow later, maybe staggered out by a month. So right now it'll be open source, but the output won't be in OCP diag format. So
why is that?
I think it is just to kind of a vendor has also been asking for it, and so they wanted to unblock the vendor as quickly as possible. It just happened to be parallel efforts. That's the only thing. Like so.
Okay, I suspect it will be much harder to add later than it would have, which is why I bring it up.
It was a discussion I had already done.
Okay, fair enough.
Okay, go ahead then.
Yeah, I was going to say, aside from maybe the SSD part, I wasn't aware that the OCP part was coming later, but we will have everything we need to validate a system now, right? We've got compute, we've got storage, we've got memory, and then we will have also the PCIe devices, right? So literally, you can do the whole core of a system at this point with the OCP diags. The coverage may not be fantastic, but we do have everything there covered. And then we can start branching out into common peripherals, I think, right? And then this will be where things kind of get interesting with, NVIDIA and AMD and, vendors like that, and how we kind of bring in some of their tools and the work that they're doing. And then I'll see if I can get permission to speak a little bit more openly about some of the work that we've got going on with them around what is currently, OCP Diag V1. But we can bring that into 2024. And then I know, Arun, you're under the weather right now, but like if we had the ability for the work that you're doing to kind of be like the test bed, the vehicle, the demonstration for this, that would be really amazing.
Hey, Dan, so what is the timeline that you have in mind?
Well, we have no external time pressure here, right? So, I don't want to create like a manufactured sense of urgency on when any of this stuff needs to land, but it is kind of becoming real. I would hope that hopefully we could get something together in Q1, I would hope, for 2024. It seems like we have all the Lego blocks now. We just need to put them together. The LNT stuff, I think, would be icing on the cake too, by the way.
So, what does that mean? Like, is that Jan to March timeframe, or is it earlier?
Yeah, that'd be like somewhere between January and March, or April, or whatever, right? I mean,
I think I like the idea of Q1, because then we'll be in good position for the talks. Not that I'm going to say much about the talks.
Yep. Fair enough.
All right.
Cool. Okay, I got to run, guys. I hope you feel better, Arun.
Thanks, man.
Okay, I think we're on time for today anyway. Thanks everyone for joining. We'll see you next week. Bye.
See you guys. Bye.